Hello everyone, myself Sahil Malik, and we are going to discuss about the topic arrays versus linked list. As we all know that in data structure and algorithms, we have basically two types of data structure. One is linear data structure, and second is binary data structure. So here we are going to know the difference between the two basic linear data structure. One is arrays, and second is linked list. As we all know that arrays and linked lists are two fundamental data structures in computer science, each with its own unique characteristics and use cases. This presentation will explore the key differences between these data structures, providing a comprehensive understanding of their strengths and limitations. So first of all, let's start with the basic definition of arrays and linked lists. As we all know that arrays are a collection of elements stored in contiguous memory locations with each element accessible by its index. As we all know that in arrays we use zero based indexing. So if we want to access element, we can directly give their address and we can access that element. While in linked list are a collection of nodes where each node contains data and a reference to the next node in the sequence. In linked list, they are basically a block which contains the data and the address to the next node, which is in the order of that linked list. So in arrays, uh, arrays are allocated a contiguous block of memory at compile or runtime, with each element occupying a fixed amount of space, which is very basic. While in linked list allocate memory for each node dynamically. Dynamically means when compile time, as they are added to the list, with each node containing a reference to the next node. So this is one of the features of linked list that in linked list the memory is dynamically allotted. So whenever we are using linked list, we don't need to give the size in previous order. Like in arrays, we are sorry for the delay. So in arrays, we are when we are defining an array, we have to give the size of that array. But in linked list, we don't need to do this because it is dynamically allocated. Moving further, so one of the feature of arrays is that arrays provide constant time and 0 to 1 access. Yeah, we go of one access to any element because we have the address of that element. We can directly reach to that element. While in linked list, we don't have the address of that element, so we have to traverse the whole linked list to reach to that particular node, which increase resulting in linear time complexity or space time complexity to big O of n. So this is one of the features of arrays over linked list. Insertion and deletion. Inserting or deleting an element in an array requires shifting or subsequent elements, resulting in linear time big O of n operations. Basically, when we want to add any element or delete any element in between the two elements, we have to again create the whole array, shift the previous elements to backward or forward, then we could enter any element. While in linked list, there is very easy process to insert or delete a node because we have the address, we can directly access the element in between the two previously inserted nodes. So it decrease the time complexity to big O of 1. This is one of the very good features of linked list. Okay, size limitations as we have discussed earlier, while creating array we have to give the size of the array, while in linked list there is no need to do this as linked list can grow dynamically with no inherent size limitations as new nodes can be added when we require it. So basically talking about the pros and cons, we have discussed that one of the features of arrays over linked list is that arrays provide constant time access, which is very efficient to use, efficient memory uses. While in linked list, pros are dynamic size, because we could declare the size at the runtime. Fast insertion deletions, we have the address, we could directly add or delete any element according to our need. Talking about cons, arrays have fixed size through insertion and deletions, which overcome the linked list, like cons, lower access time, more memory overhead, like this. So if we talk about the conclusion, we could say arrays and linked lists are both fundamental data structures with their own unique characteristics. Understanding the differences between them is crucial for designing efficient and effective data-driven applications. If we could understand the basic difference between arrays and linked lists, we could use them according to our need. So whenever we want to access any element, we could use arrays because we have zero, we go of one axis. And if we want to add insertion deletion, or we are doing any work where we want to continuously add some elements, so we should proceed with linked list because they allow us to add any element according to our need. That's all from my side. Thank you everyone.